My guest today is Dr. David Diamond, PhD, a neuroscientist and professor at the University of South Florida. He is the former director of the university's Center for Preclinical and Clinical Research on PTSD. David has also developed a special interest in cardiovascular research when confronted with a health crisis of his own over a decade ago, and has contributed to many recent papers in this space. David, really appreciate you taking the time today.
Well, thanks for inviting me to be on your show.
Terrific. Well, maybe we can kick things off here with you telling folks a little bit more about how you got interested in the cardiovascular research side of things.
Sure. So about 20 years ago, when I was in the middle of my neuroscience career, I was 40 years of age at the time, I actually had a blood test to be able to get life insurance, and I was very surprised to see they put me in the highest risk category, greatly increasing the cost of my life insurance. And I thought it must have been a fluke because they had my triglycerides at about almost 10 times what would be ideal, and my HDL was so low. I didn't know what they were, but I knew they were very bad. And then decided to go on a low-fat diet and exercise like crazy. And every time I'd see my blood test results, since I failed. Couldn't get my triglycerides below 700 and couldn't get my HDL above 32. And that combination put me at very high risk for developing heart disease. 10 years of failure led me to my doctor. Literally, we just sat down and we looked eye to eye, and he said, you're going to have a heart attack if you continue with this. You've done your best. You've exercised, you've dieted, and it just didn't work. You must go on a statin now. I didn't know what a statin was. I didn't really even know what triglycerides were. I was a neuroscientist. That was my training. And I was actually quite amenable to taking the medication as long as I saw that it was safe and effective. And I just figured, well, the thing to do is use my biology background to learn a little bit about statins and learn about the triglycerides, the hypertriglyceridemia that I had. And if the best strategy is to take the meds, well, then I was ready to do so. Just went back to my office. I read a few papers on triglycerides and just saw it was so obvious. I mean, triglycerides are produced from excess glucose. So the solution was very simple. I just needed to stop eating carbs. From there, things really developed. And in the last 10 years, what I've learned is that I was eating too much sugar, bread, and potatoes. Cut back on all those. I was actually getting pretty fat, too, at the time. I lost about 30 pounds since then, dropped my triglycerides by 75%, increased my HDL by 25%. Much healthier now than I was 10 years ago. And I've had the opportunity to share with people at conferences and in publications what I've learned and why it is that statins ultimately aren't healthy, and it's not healthy to lower your cholesterol, frankly, by any means. There's the story.
That's a great synopsis there, and a great segue to kind of jumping off point here to talk about cholesterol and, of course, cholesterol phobia, or the fear we've had over the last few decades. And perhaps you can get all the listeners on the same page here. We've got docs, nutritionists, trainers kind of listening in. So can you briefly walk listeners through a little bit of the history and the origins of hypercholesterolemia, or high cholesterol, and the heart disease connection?
Sure. So there is a disorder called familial hypercholesterolemia, which as soon as you had blood test results, which were developed in the first half of the 20th century, you see an association in which there are people from childhood had extremely high cholesterol levels, which is a genetic disorder. And you do find that sometimes young people, even children, teenagers, people in their 20s, have a heart attack with this disorder. So you have people that have high cholesterol. You have cholesterol actually in the arteries. You see people young developing heart disease. You put that all together, and it's just logical to assume that the cholesterol is causing the heart disease. And that's actually what's promoted the fear of cholesterol beginning really in the 1950s, and then continuing on, frankly, to the present day. And one of the first approaches to treating cholesterol actually was to use vegetable oil, and specifically corn oil. There actually is a first clinical trial to lower cholesterol in people that were very high risk for developing heart disease was to use corn oil. And you had people told to cut back on saturated fat, which is another topic we can talk about.
For sure.
And they had a few tablespoons of corn oil every day. And compared to placebo, in which people were basically told, go home and, you're at high risk, you're going to be the control group. And unfortunately, they were expected to have very high rate of heart attacks. Well, 3 years later, the people with dramatically lower cholesterol as a result of using corn oil had almost twice as many heart attacks and died compared to the people that didn't use the the corn oil and higher cholesterol. And it's published in British Medical Journal in 1965. And it's remarkable to me that people have ignored that paper, and yet they still see corn oil as being heart healthy. And this fit with sort of the misunderstanding, really, of physiology that was developing in the 50s and 60s. And I've talked about it, and people now become very familiar with our Ansel Keys, who knew nothing about heart disease, knew nothing about nutrition, became the leader in the 1950s and into the 1970s. And he really misled everyone into the diet heart hypothesis, in which the idea he had was if you consume animal fat, which is primarily saturated fat, that would ultimately clog the arteries and cause people to have heart disease. And it was completely wrong. There was never any support for that hypothesis. And yet it continues to this day.
Yeah, absolutely. And then, if we sort of shift over into the 1980s, if we stay on the cholesterol story here, and lowering cholesterol became a real primary clinical goal in that decade, based on a few influential studies. So could you maybe discuss some of the early research and the Mr. Fit study and some of the claims that were made, and if they're supported by the data?
Right, and I've lectured on this as well. So first of all, there was a very long, very expensive study, about 7.5 years, in which you had middle-aged men with the highest cholesterol. They actually tested 500,000 men and had those that had the highest cholesterol, averaging about 270 total cholesterol. And they were the ones included in this study. The assumption was that having extremely high cholesterol would then increase the likelihood that they would die of heart disease. This is the LRC study that was published in 1984. And then it was a relatively primitive drug that's actually still used now, which is cholestyramine. And it's a bile acid sequester, which actually binds to cholesterol and simply removes it from the body through the colon. And you can dramatically lower cholesterol using the cholestyramine. So they had these men on either cholestyramine or placebo for 7.5 years. And there was a dramatic reduction in cholesterol for the men taking the cholestyramine and no change in the men that were on the placebo. And the findings were unequivocal. There was absolutely no difference in outcome between the men that had the lower cholesterol and the men that had the placebo. And this, I think, is documented as the first time deception has been used to amplify minuscule effects. What they did was take a difference. Literally, you're looking at a difference of about 8 men in the placebo versus cholestyramine group, beginning with 500,000 men, down to about 3,500. 8 men, which was not statistically significant, but what they used was relative risk, in which you can amplify a minuscule effect and make it appear very large. And so that 0.4% difference between the two groups in terms of coronary events, you can then change that into what's called relative risk, and you convert it into a 24% risk. And this is how they advertised their effect. They said we can lower cholesterol and reduce heart disease by 24%. And that 24%, again, is just statistical deception, which I've published a paper on about that. So that was the LRC study published in 1984 in the Journal of the American Medical Association. The Mr. Fit you're referring to, one of those, Mr. Fit, which tracked a few 100,000 men, and they looked at their cholesterol levels and related to heart disease. And this was a frightening kind of paper because they said that you had to have cholesterol absolutely as low as possible. You want your total cholesterol to be at 150.
Wow.
And that literally is their reference point is 150, which we know is an unhealthy level of cholesterol. And what they said was that for every small increment of 1% increase in cholesterol, you would increase your risk of heart disease by 4%. And so people with a cholesterol of 300 would have a 400% greater risk of dying of heart disease compared to someone whose cholesterol was 150. And this deception is just, it's a travesty when you look at how this was deceptive. The actual difference in rate of heart disease between people with their cholesterol at 150 to 300 was 1%. 98% of the people in Mr. Fit, and this is following 350,000 people, 98% of the people did not die of heart disease. And yet what they did was they took the difference across the entire physiological range of cholesterol, which was a 1% difference. So the people at the highest level of cholesterol, 98% of them did not die of heart disease. People at the lowest level of cholesterol, 99% did not die of heart disease. The difference was actually 1%. But again, using relative risk, it allows you to amplify effects, and so you can create huge effects. That's how they created this 400% increase in death from heart disease. It's something that people who have, in a sense, declared war on cholesterol, made us fear it, they've been using this kind of statistical deception now for decades.
Yeah, staggering stuff in terms of the numbers, and of course, this led to the classic Time magazine photo in the 80s with the eggs and the bacon frowning and this fear of saturated fats. And
exactly. Let me actually tell you,
sure,
that article and that Time magazine cover was about the paper I just told you about, in which there was no statistical difference between the two groups with lowering cholesterol and not, and that was a pharmacological study. It was not a diet study. And yet when it was reported in the media, they demonized dietary cholesterol, which had nothing to do with the study, and they demonized serum cholesterol as well. So in a sense, we really have to understand that there was an outright campaign to sell the idea that cholesterol caused heart disease, when in a sense now for decades, lowering cholesterol had failed entirely, and associating total cholesterol to heart disease had entirely failed. Now that problem, though, the problem was you had the Nobel Prize winners, Goldstein and Brown and Goldstein in 1984 had written a Scientific American article saying LDL cholesterol causes heart disease. Well, once Nobel Prize winners say that something causes a disease, it had to be accepted as fact. And yet we now know that even LDL-c is not very well correlated with heart disease, and people have generally given up on LDL-c as well. So this was the 1980s, was a time when the cholesterol theory was failing. It was failing because cholesterol was not well associated with heart disease. Lowering cholesterol by means prior to the statins had not had any effect, any real effect on heart disease. But Brown and Goldstein won the Nobel Prize for showing that the LDL receptor was associated with heart disease. Therefore, the entire field was devoted to finding new drugs to be able to lower LDL.
Yeah, it's fascinating stuff. And of course, you mentioned, obviously saturated fat intake being sort of a key focus point to reducing animal foods, because obviously they contain that. Years ago, I spent a year living in the south of France, and of course, the cuisine there heavy in things like duck fat and pâté and butter and cheese. And of course, the diet over there, somewhere around 40% of total caloric intake comes from fat, much of which is from saturated fat. And I know you've written and spoken about this here, but how does saturated fat impact death from heart disease in the French or the trend in other countries as well?
Well, this is remarkable because I'm an outsider to this field. It's almost as I'm looking in on a field that has been hijacked by horrid science. I mean, I'm appalled when I look at nutrition science as an outsider. And again, I bring up Ansel Keys. Ansel Keys, again, was a person who in the 1950s gained so much acclaim because he was a self-described expert in heart disease and diet. Ansel Keys decided that saturated fat was the cause of heart disease, in the complete absence of any evidence. And there has not been any evidence that saturated fat alone contributes to heart disease. Now, when you ask people, what do you eat? And they'll tell you, well, I eat cheeseburger, French fries, ice cream, and soda. Somehow Ansel Keys only heard cheeseburger. And from that, he didn't even get that a cheeseburger usually has bread with it. And he didn't care that people were drinking soda and eating lots of sugar and eating candy. He focused on the saturated fat, which is found in the meat. And that's what so many other epidemiologists have done. they focus on the fact that there are individuals who do eat a lot of meat, and the people who eat the most meat in Western civilization also tend to eat the most sugar. And that combination is unhealthy. It's pretty obvious. But there have been some great studies that have come out. Zoe Harcombe is one whose PhD work was to actually evaluate the studies that were available when Ansel Keys was around and since then. And you've got so many individuals now that have taken a close look at saturated fat per se, specifically animal fat. And when you separate the sugar component, when you separate the carbohydrate component from the fat, what you see is that there is no association between saturated fat consumption and heart disease. For example, I mean, what's been so demonized, what I was afraid of 20 years ago, was consuming eggs. I mean, eggs are loaded with saturated fat and cholesterol. And so people are afraid to eat eggs. And as it turns out, eggs actually raise HDL, which is a good thing. Eggs don't actually have any much of an effect on total cholesterol. But ultimately, it's one of the healthiest foods that a person can eat, is to have eggs. So this is part of the misinformation we've been given as far as diet and health.
Absolutely, and I recall Dr. Harcombe giving a presentation where she points out the amount of saturated fat in 100 grams of almonds being much more so than in 100 grams of a steak. And so some of these things that people just take for granted and don't get into the details, because of course we're consuming all types of fats in the foods that we eat. And
well, that's a misunderstanding, which I think has been promoted in part by the food industry. And so they want to sell the low-fat food and people want to promote certain foods. But part of this is also philosophy. I don't think this is all just about profiteering. I mean, there's a powerful vegan movement which wants to demonize meat simply because they just think it's wrong, and they like to point to epidemiological studies in which you have people who, again, are eating a lot of meat and smoking and eating a lot of sugar who have poor health, and they seem to put blinders on to ignore the smoking and the sugar component. So part of this is dealing with individuals who have a philosophical objection to the consumption of meat, and they influence in how people think about consuming meat.
oh, for sure, and the discussion on obviously total cholesterol seems to have passed a little bit, obviously in big pharma as well as even in doctors' offices, of moving away from that. The conversation now, which we're having around saturated fat, and the evidence that you point to is obviously highlighting the fact that it's not dangerous for folks, especially if they're getting this from real food. Yet there's still a decent amount of experts and others out there who are skeptical about raising the levels of saturated fat in one's diet and do believe that it should be replaced by polyunsaturated fats. Can you maybe speak to some of what you believe their reasons might be and some of the shortcomings there?
Yeah, so again, you mentioned before the French, and you had spent some time in France, and I've been to France numerous times, and it's remarkable to me that Ansel Keys completely ignored the French diet. He ignored the Swiss diet, which is also very high in fat in general and saturated fat. In fact, France has the highest percentage of fat in the calories of any European nation, and the highest percentage of saturated fat per total calories. And you actually can see in nutrition journals, it's been shown that the French have the lowest rate of heart disease of any country in Europe, and certainly much lower than that in the US. And what's happened is people just are choosing to ignore it. And I've never seen in science, I've been in science 40 years, I have never seen any other area that uses the word paradox more often than the nutrition area. I mean, in every other area of science, when you have data that are contrary to the hypothesis, you change the hypothesis. You don't just call the data a paradox. And only in nutrition do they just continually call something a paradox. So what you have is the French paradox. And you see these people, Walter Willett, Ansel Keys, who scratch their heads and say, I just don't get it. How can the French eat so much fat and not have heart disease? And then they call it the French paradox. Now what they'll do is they'll say, well, the French doctors don't know how to diagnose heart disease, which is absolutely absurd to say, well, they don't even know what heart disease looks like. But the other thing that's so clear, you've been in France, anyone who goes to France knows that these people are so terribly thin. Obesity is so rare in France. And it's for two reasons. When you eat a higher percentage of food as fat, you actually feel more full, and you actually ultimately consume fewer calories. And so that's a really great thing about a higher fat, low carb diet is it triggers the sort of natural hormonal response, which then produces satiety. And part of the reason why low carb diet is effective is because you actually consume fewer calories and you don't have those big swings in blood sugar. The science is entirely on the side of high fat in the context of a low carb diet is extraordinarily healthy. I've also lectured and covered how when you include fat in your meal, you're much more effective at absorbing nutrients, much more effective at absorbing antioxidants and minerals. And by actually, frankly, having more fat, and this will surprise people, by reducing the plants in your diet, you have more efficient absorption of minerals. And this I credit Georgia Ede, especially for a lecture she's given that I've seen, in which you can see that plants actually have what's called anti-nutrients, phytates and lectins that can interfere with absorption of minerals. So ultimately, it's really, the irony is that one of the healthiest foods you can eat is basically animal products, whether it's meat or the organs. They are the ideal food one wants to have if you want to optimize nutrient absorption and overall health.
Yeah, it's definitely something that in France as well as all over Europe, of eating nose to tail and consuming real meat and the whole animal and organ meats is part of the diet. And of course, in places like North America, Canada, the U.S., even the U.K., over 50% of the households purchasing on food is on processed and ultra processed food. And when you go to places like France, it's like 18% or 16% in Spain and 12% in Italy. So you can see that, as you mentioned, just getting back to real food and having that approach is pretty key. Now, if we talk about and shift gears a little bit to statins, as they're sort of obviously the gold standard approach to treating high cholesterol or high LDL levels, can you talk a bit about some of the original research on statins like Lipitor and Crestor?
Okay. So before we get into the statins, I would like to briefly cover another category of medication, which is as effective as the statins in lowering LDL, but in addition raises HDL, and that's the CETP inhibitors. And what they do is they interfere with the conversion of HDL into LDL. The result is that you've got elevated HDL, which is called the good cholesterol, because higher HDL is associated with less heart disease, and at the same time, it lowers LDL as effectively as the statins. And the results are absolutely clear. Here it is 20 years later. Tens of thousands of people have been tested in multiple trials. Drug companies have spent billions on what should have been a blockbuster drug. And there's absolutely no difference whatsoever with the people with lower LDL with the CETP inhibitors compared to the placebo. And so to me, that right there tells you that lowering LDL does not have any benefit whatsoever on coronary events. That leads us now to the statins, which are the HMG-CoA reductase inhibitors, acting by a different mechanism in which you block statin production or block cholesterol production directly with the enzyme that is in the pathway of producing cholesterol. So it's a different mechanism from the CETP inhibitors. And the statins have side effects, pleiotropic effects, in which statins also have an anticoagulant and anti-inflammatory effects. So it's in a sense much dirtier, having more side effects than the CETP inhibitors. Mm-hmm. And with the statins, what you do find is a relatively small improvement in outcomes. Those outcomes actually were relatively large in the first couple of studies. And you have the 4S, which I do simvastatin study, which is in the 1990s. This is the largest effect probably ever published, in which people were given simvastatin, and you had about a 4% reduction in coronary events and mortality. And this is a study that's never been replicated. It was designed, run, data were entirely analyzed by the drug companies. And frankly, no one should believe those findings. They have not been replicated. The more recent studies have shown maybe when there is an effect, it's about a 1% benefit when you compare people taking the statins versus placebo. And even then, you're only talking about coronary events. You're not really looking at coronary mortality. Absolutely no benefit whatsoever when you're looking at primary treatment, which is for people who've never had a coronary events, and about a 1% to 2% benefit for people who have already had a heart attack. So the real effects, I think people don't know, is when a doctor says, well, we're going to reduce the likelihood you're going to have a heart attack with a statin, they really should know that that difference is only 1% different from someone who takes nothing, takes a placebo, which means that 1% means that only 1 out of every 100 people using Lipitor or Crestor, only 1 person will have 1 less heart attack over the course of about 4 years. So the benefit really is meager with the statins.
And when you look at that, is it back to the same story around how they're using the data with relative risks versus absolute risks in terms of some of the points that they're raising of 36% or 44% reduction, things like that?
Right. So then, again, I've mentioned relative risk before, and this is extraordinary to me that people get away with this. What relative risk means is, again, we're talking about a 1% benefit. So let's say 2% of your people on placebo have a heart attack, and 1% on the Lipitor have a heart attack, which I think is very important to realize. That means if you do nothing, you have a 98% chance of not having a heart attack. And I think it's very important for people to realize.
It's impressive, isn't it?
And I'm getting this directly from the studies. I'm not making this up. I mean, most of the studies, you're looking at about 96 to 98% of the people do not have a heart attack, and almost all of them do not die. Okay, so we begin there. But now when we look at the 2% to 1%, the real difference then is a 1% difference. But what will you see in the ads? What will you see sold to the doctors in their training? What will you see told to people? And this is often the only statistic you will see, is that this Lipitor reduces heart attacks by 50%. That 50% means you're going from 2 to 1. So 1 is half of 2, so you say it's a 50% reduction. But that's a distortion of the data, because really you're changing it from having a 2% chance of a heart attack to 1%. The real difference is 1%. Now, with that said, I have lectured to physicians because I was at the VA for 30 years and I gave lectures to physicians there, and I've lectured at cardiology meetings. The doctors will still say, well, that's better than nothing. So at least 1% of my people on the statins won't have a heart attack that they would have had they not been on a statin. And that's a very reasonable thing to say.
Absolutely.
And I would agree entirely. I'd say, fine, then people should be on a statin if there were no adverse effects. And this is where pharma has basically had control over, to a great extent, as to what's reported about adverse effects. But when you actually look deep into the literature, you find adverse effects are prevalent. We actually had a review. I have a review coming out in Public Library of Science, PLOS One, in which we reviewed over a dozen adverse effects of statins. We've 60 published papers on the adverse effects, with the leader. The most common adverse effect is the development of type 2 diabetes in healthy people who take statins. And when we're talking about a doubling of the rate of diabetes in people who take statins, not talking about going from 1 to 2%. Study very clearly showed that in people getting placebo over the course of about 5 years, about 5% of them spontaneously develop diabetes. But in those on statins, you're looking at about 10% develop diabetes. Wow. So it's an extra 5% of the people who were healthy develop type 2 diabetes, and that can be related then to the statin that they're taking.
Yeah, it's really compelling stuff. And if we circle back to that discussion around LDL cholesterol, because obviously things have now shifted away from total cholesterol, statins also lower LDL cholesterol, the supposed bad cholesterol, as you mentioned, and obviously claim to lead to hardening and narrowing of the arteries, because obviously it's acting as a ferry or water taxi, delivering fat molecules to cells. So could you circle back and talk a little bit more about your research in this space on LDL and that recent systematic review in the British Medical Journal?
Sure. So the review that I had the great pleasure to write with over a dozen MDs, including cardiologists, we reviewed every paper that had been published on coronary mortality all-cause mortality in older people. Basically, you're talking about people who have the greatest likelihood of dying from heart disease. That's all people over 60 years of age. We did not find a single paper that showed premature mortality in people with the highest levels of LDL-c. And in fact, the vast majority of the people that were studied, that's older people with the highest LDL, showed greater longevity than people with low LDL. And so that was actually the first study that specifically our review targeted studies on LDL and showed, in fact, that if you have high LDL, you can expect to live longer than if you have low LDL. And related to this, again, getting back to familial hypercholesterolemia, these are people who have cholesterol that's like 400 is their total cholesterol, and their LDL-c is about 250. And the American Heart Association recommends you be below 100. These are people at more than 2 times the level of LDL-c. And I've covered this in a recent review. We have a paper on familial hypercholesterolemia in which if you're 60 years of age, you actually have a lower rate of death and no greater increase in cardiovascular disease if your LDL is 250 and your total cholesterol is over 400. This really surprises people. But what people really need to understand is LDL was not created simply to block people's arteries. LDL is an essential part of our health. It's an important part of our immune system. People with the highest levels of LDL have 1/10 the rate of cancer that people with low LDLs have. People have significantly lower inflammatory disease and immune disease. People with the highest level of cholesterol. And that's often what kills older people, would be infection. So people need to understand that high LDL is actually healthy. The last thing you would want to do is muck with your LDL, since it's actually associated with longer life and better health.
Terrific. And David, what about particle number? Studies indicate that risk for atherosclerosis is more related to the number of LDL particles than the total amount of cholesterol within these particles. So
Right.
could you shed some light on how that relates to heart disease?
Yeah, I'm glad you asked about this. And in fact, I just gave a talk a couple of weeks ago at the University of Houston at a low-carb meeting, and I covered LDL-c versus LDL-p. So what's happened is the war on cholesterol had to retreat from total cholesterol, which failed as a marker of heart disease, to LDL-c, which is a measure of total cholesterol within the LDL, now to LDL-p. So what you've got is LDL is packaged in lipoprotein, and you can actually monitor and measure each lipoprotein itself by actually counting the number of ApoB particles. Each LDL has one ApoB particle, but the amount of cholesterol inside the particle can change. That's the LDL-c. So a paper came out some years ago, and there's been some support for this that shows a better correlation of coronary events to LDL-p instead of LDL-c. Well, I actually lectured on this, and I showed that the people who have higher LDL-p are the ones actually that have higher blood sugar. They're more likely to smoke. They have more diabetes, more metabolic syndrome, dramatically higher triglycerides. I mean, doesn't this tell you something? It means that LDL-p is another marker of an unhealthy lifestyle. If a person has high blood sugar and they happen to also have high LDL-p, why would you want to conclude that it's LDL-p that causes the heart disease? The high blood sugar, the high triglycerides, the low HDL, these are all markers of an unhealthy lifestyle. So all this going on about LDL-p is simply because LDL-c has failed. And so what the lipidologists are looking for is another lipid that can be blamed for causing heart disease. But it's simply a surrogate marker for an unhealthy lifestyle. So if you want to change your LDL-p, you want to change your HDL, your triglycerides, you want to be able to reduce diabetes, and you basically want to improve performance in sports as well, is basically cut back on the sugar, go low carb, and increase consumption of fat. It's frankly the best way to optimize all biomarkers.
Yeah, it's a great point of using that LDL-p as a surrogate marker for that lifestyle and lifestyle medicine, and changing those things around nutrition and movement, and whether it's sleep or stress management and those things. So that's really insightful. And Doc, Prof, rather, I recently had a chance to listen to Dr. Peter Attia's in-depth discussion with lipidologist Thomas Dayspring, which, I think it was about 5 lectures worth of, pretty deep dive into this sort of conversation. And, they had talked around things like ApoB, apolipoprotein B, and of course LP(a) in this whole discussion on heart health. Can you talk to listeners a little bit more about where the research is at the moment in terms of LP(a)?
It's a little difficult for me because I listened to their discussion, and I'm holding back because they're two very bright people, two very knowledgeable people, and it's remarkable to me, especially with Peter Attia being an advocate for low-carb diet, that they can be so blind to the actual cause of heart disease, why they both cling to the idea that LDL in some form, whether LDL-c or LDL-p, actually causes heart disease. They kept saying it over and over. LDL-p causes heart disease. And I almost pulled all my hair out. It was really terrible at my age to pull my hair out. I couldn't afford to do that. But I was going nuts because they're clearly aware that when you look at the different LDL forms, and Ron Krauss has done such nice work on this as well, that what you find is that with high blood sugar, you have, in a sense, a shrinking of the LDL. You have the small, dense LDL, which is associated with heart disease. But really the question is, what you want to distinguish between association and causation. LDL, in a sense, is damaged by high blood sugar. It is damaged when people smoke, when people are sedentary, when people are obese. How can you blame a damaged protein, a damaged cholesterol, on causing the disease when what you want to do is get back to the undamaged form? And so the undamaged or native form is one that is not affected when you have high blood sugar. So ultimately it gets to the low-carb diet helps to increase the size of the LDL, which is associated then with less heart disease. So again, I don't understand why these two very bright people just can't seem to get the idea that it's stress and blood sugar and sedentary diet and obesity that's contributing to the heart disease. Now, even LP(a). LP(a) gets back to the broader scheme that I've lectured on, which has to do with coagulation. People, of course, accept that a clot can cause a heart attack or a stroke. But what they don't understand is that there are so many different influences, including LP(a), that have to do with clotting from the very beginning to trigger atherosclerosis. And LP(a) has to do with fibrinolysis. And so it's related actually to fibrin, it's related actually to clotting. And people with high LP(a) actually have reduced fibrinolysis, which is the body has a natural ability to break up clots. And when you have high LP(a), you're impaired at breaking up clots. So again, what do? Do you take medication to lower your LPA? No. What you want is a strategy to reduce the likelihood that you're going to naturally be forming clots. And what forms clots? Coagulation, activation of your platelets. Again, it all gets to high blood sugar, being obese, smoking, stress, all activate platelets. And so we literally have these clots going through our bloodstream as a result of an unhealthy lifestyle. And if we want to get to what actually triggers atherosclerosis, we have a microvasculature in our coronary arteries called the vasa vasorum. These are tiny arteries that are relatively easy to get blocked. These are the arteries that actually feed the center of the coronary artery, the intima. And so when these tiny arteries are blocked, and this has been studied, this is my idea, this has been around for decades. When these tiny arteries that feed the inside of the coronary artery, when they get blocked, the inside of the artery literally, it dies. It becomes necrotic because it's hypoxic. And so what happens at that point is you have to have cholesterol coming in along with white blood cells to repair that tissue. You find bacteria invade the center of the coronary artery, and so the LDL, along with white blood cells, kill the bacteria and remove the viruses. And that is, in fact, how the plaque develops. The plaque develops from death, necrotic tissue in the middle of the artery. As a result of repeating that process time after time over decades, the artery wall thickens until eventually the lumen, where the blood flows, gets choked off, or the atheroma, which is that growing plaque, erupts into the artery and then causes a heart attack and people die. So if you're really looking for the cause of heart disease, you've got to look at hypercoagulation and insufficient fibrinolysis. And what's the way to fight both of those? Frankly, it's not with medication. It's not taking aspirin. It's not taking any drug to change that. It is just so easy. And the way to do it is to keep blood sugar low, is to moderate exercise, not be sedentary, and certainly not to smoke. This is the ideal way to keep those platelets from getting so activated that they block our blood vessels.
Yeah, very well said. And in terms of that, stickier or sludgier blood for the listener, if those platelet aggregation is increasing.
It's thicker. Literally, the blood does get thicker and flows more slowly. In fact, in response to stress and smoking and being sedentary and being obese.
Absolutely, and I've heard you mention in your talks those factors, those lifestyle factors. You mentioned, smoking, high blood sugars, obesity, stress, hypertension, familial hypercholesterolemia, inflammation, and advanced age, obviously being places for people to start, and those lifestyle factors being kind of the big rocks. Would that be
right?
Your opinion still on how to tackle this stuff?
And it's not such a big. Well, I tell you, the real problem. I can say it's not a big deal, but the real problem is that people who smoke and are overweight and they're eating a crappy diet, they're going to their doctor to take a pill to be able to reverse this unhealthy lifestyle. And I think that whole attitude needs to change. You don't have to work out. I was actually working out 5 days a week. I was killing myself because I thought that was the way I was going to lower my triglycerides. I think people need to understand that, first of all, if you smoke, forget it. There's no pill that's going to reverse the hazards caused by smoking. So you just simply have to stop that. And I see obese people, and I just feel so sorry for them because I see them having diet food. I see them having, low-fat food, and they've just been poorly educated to not know what it is they need to eat to be able to lose the weight. And so subtle changes in a person's life can have such a dramatic difference. Just getting out and being active, not smoking, controlling stress, reducing the amount of bread, potatoes, and sugar in your diet, and enjoying food high in protein and fat. Go out and enjoy a steak, just don't have the potato. How hard is that to do? That's the way I look at a lifestyle change.
For sure, and it's definitely something that working downtown Toronto, I work a lot in men's health, and a lot of guys between the age of 35 and 75 who are in a situation where they are potentially at higher risk, and low carb's definitely been an effective nutritional strategy to help to achieve a lot of this stuff, and that caloric restriction that you mentioned before, which is a key part of this as well, happens naturally on a low carb diet because you're excluding all those, the majority of the processed foods that folks eat. You get more vegetables, you get more protein, you do get the natural fats that people are eating in food. So it can be a great strategy. Now, for some folks listening in, they might say, well, you could accomplish this with a low-fat diet if they were in a caloric deficit. Is that something that you would agree with if the person was able to maintain it, which I think sometimes is harder in practice than in theory, but what are your thoughts there?
No, I think that's completely the wrong kind of thinking. The goal is not a caloric deficit. The goal is not to lose weight. The goal is to be healthy. The first thing that is so important is to understand when there is fat in the meal, you absorb nutrients more efficiently. There's so many studies, first of all, that show that. When there is fat and protein in the meal, you feel full. You naturally have negative feedback. You naturally feel full, so you will consume fewer calories. You don't even have to count calories. That's what's really important about the low-carb diet. The only thing you're keeping track of is carbs. And since I have a carb budget that I allow myself each day, I do count carbs, and I try to stay below 50 grams of carbs per day. I don't have to count calories to be able to maintain good weight and, in fact, to be able to lose weight. So the first thing is weight loss is not the goal. Healthy living is the goal. And the way to be healthy is to have natural sources of protein and fat. So that's really the first point. And in fact, the real problem is when you have people that go low calorie, especially low fat, they will lose weight. But what's happening is they've now got insulin receptors that have gotten more sensitive. And as soon as those people reach their target weight and they want to celebrate, it doesn't take long then to be able to have that increased insulin sensitivity, which is now going to dramatically increase fat deposition as soon as they start eating more carbs. And so what I emphasize to people is low carb is not a dieting approach to lose weight. Low carb is simply something that is natural. It's what we evolved to do. It's a lifestyle choice. It's something you do for your entire life. You don't do it to reach a target goal. And let me just add something, by the way. We had talked about familial hypercholesterolemia earlier.
For sure.
And we did just publish a paper. I think it's very important for people to understand. About 1 in every 400 people is diagnosed with this, and they've been frightened into taking statins. And of course, we're going to be careful here. I'm not giving any medical advice, but I am giving information. Only a subset of people with FH actually develop heart disease. And so the question is, why did these people, with their LDL being 250, develop heart disease when other people with FH, with their LDL at 250, do not develop heart disease? And the difference, again, gets back to clotting factors. Fibrinogen is one. The people who have extremely high LDL and clotting factors are the ones who develop the heart disease. So again, what you want to do is keep those clotting factors low and keep them calm. And so the people with FH who also smoke are the ones that have extremely high rates of heart disease, or those who have diabetes, very high rate of heart disease. So the most important thing for a person with FH to do is to be able to be sure that they have low blood sugar, that they exercise to control their stress. And if they do that, they've dramatically reduced their risk of developing heart disease.
David, that's a fantastic, terrific insights here today, and definitely want to respect your time. So before we wrap up, a final few questions for you. The first one is, you're now lecturing to cardiologists, you're writing in cardiology journals. What's the evolution of research in this space?
Oh, wow. It's a great question, and I'm not a pessimistic person by nature, but it's very frustrating because I still see a dominance in the field of pharma-supported researchers. I see a dominance by the American Heart Association, which is to a great extent supported by food and drug companies. So the control still in this field is by those who have perpetuated the fear of cholesterol. And when you've got at least 25% of older adult Americans now taking a statin, and they're projecting that it'll be as much as half of all adults on statins, it's hard to be optimistic. But my colleagues and I are getting the papers out there. We have opportunities to lecture. I see low-carb diet now becoming promoted more by medical establishment. So I'd like to be optimistic right now, cautiously optimistic, that low-carb is really becoming much more commonly accepted, with the caveat that people fear that when they're on low-carb, if their LDL goes up, then they'll go on a statin. So while both I'm optimistic about low-carb being accepted, I'm still concerned that we're not able to get the information out there about LDL in any way, shape, or form causing heart disease. But that's my goal for the future, is to get these papers out there on the real science.
And that sort of dovetails into my last question, which is, for yourself as a career scientist, how can getting back to some of these sound scientific principles in this space help to elucidate some of these answers that we need to get to?
Well, fortunately, I'm in academics, and I'm in a position to be able to publish in medical journals. I have some credibility because I'm a professor at a university, and I got a PhD in biology. So that sort of gets me in through the door to be able to have sufficient credibility and background to be able to share this information. And I've been working with just an outstanding group of MDs and PhDs, and I really want to give credit to Ufi Ravenskov, who's been providing this message now for decades, and I depended on him heavily when I was learning about, since a lot of the problems with cholesterol, and there are just so many others. I'm reluctant to mention anyone because I know I would leave out people who are influential in this field, but the important thing is that we've got a lot of really good MDs and PhDs who have been alerted to the deception in this field, and they're getting the information out there. I'm working with Michelle DeLargeril, Paul Roche, and Malcolm Kendrick, And they're just such great MDs that I'm working with that I believe in time we're going to be able to get that information out there to be able to influence people.
David, fantastic. Really appreciate you again taking the time today. And where can people stay connected with you and keep up with all your fantastic work and research?
Well, I don't, I don't have a book. I don't have a website. I'm not promoting anything. I'm really just in a position where I want to share information, so I have absolutely no conflict of interest. And I do have people who contact me directly at my university site. So anyone's welcome to go to my site, the Department of Psychology at University of South Florida. I don't give any medical advice. I do get a lot of people who contact me and ask me what they should do, and I always say there's really nothing I can do. I can they'll give them information. So I'm available by email. I'm on Twitter. My username is LDL Skeptic.
Perfect.
And so that's really perhaps the best place to be sharing information and to be learning about what I've been publishing and my views on cholesterol and diet.
Fantastic.